Hi, welcome to the Olympiad geometry. Let's continue our study on Orthocenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So today we're going to talk about the Orthocenter and the Simson line. If the audience are familiar with the Simson line, that's good. But if you are not familiar with the Simson line, please refer to the videos I made before. So the reason I want to talk about the Orthocenter and the Simson line and put them together as a small topic, just because if we think about how we get the Orthocenter, is that we find the projection from the vertices of a triangle to each edge, right? And then we find the concurrent point of the three altitudes, that's the Orthocenter. And if we think about how we get the Simson line, we find a point on the circumcircle or a triangle, and then we do the projection from this point to three edges, and the foot are collinear. That's a Simson line, right? That line is a Simson line. And you can see the similarity of these two things, right? Because how we get the Orthocenter, we do the projection in a triangle on three edges, right? And how we get the Simson line, we do projection from a point to three edges. So I want to put them together, and actually this is a very classic figure. Lots of problem can be think of from this figure, and this can be very deep. Okay, let's just check out the two problems here. The first one is to prove the Simson line of any point P on the circumcircle of triangle ABC equally divide PH, where H is the orthocenter of triangle ABC. Okay, so basically we want to prove that say that PH intersects the JKL on point Q, right? And we want to prove that Q is a midpoint of PH. In other words, if we find the midpoint of PH, we want to prove that the midpoint Q is on the Simson line. So if we directly to prove this, it's kind of difficult, right? But let's just again, in the Chinese version of the video, I do the problem in the forward way. Okay, so for here, I do it in a reverse way to show that how I think of the problem. Let's just assume that PQ equals to HQ and see what we can get here. Because angle KQP equals to angle HQL, right? These two angles are equal. And we know that PK is perpendicular to BC and HD is perpendicular to BC, which means KP is in parallel with HD, which means this angle, the angle KPQ, equals to angle QHD equals to this one. And based on these two are equal, we can think of if we extend the HD, okay? If we extend HD, let me just remark here as the point D, right? Call this new point as S. Okay, so this point is S. So then we know that triangle KQP and triangle HQS are congruent, right? That means KPSH is a parallelogram. So the problem becomes that if we can prove KPSH is a parallelogram, then we directly prove that KS and HP equally divide each other, right? Which means the midpoint of pH is on the Simson line. So how can we prove that KPSH is a parallelogram? We already know that KP is in parallel with HS, right? So if we want to prove that KPSH is a parallelogram, we have two ways to do that. The first way is that we can prove KH is in parallel with PS, which would be difficult because hardly to find any angles that can relate these two together. And another thing is to prove KP equals to HS, right? So if KP is parallel and equal to HS, right? Then we know that KPSH is a parallelogram, right? So we want to prove that KP equals to HS. Again, it's still kind of difficult to do that. So the way I think of is to extend AD, right? And intersect the circumcircle on a point, let's call it H prime. We already know that HD equals to DH prime, right? HD equals to DH prime. So we find something equal here. And now we find the symmetrical point from P to BC. Right, let's call this point as P prime. And we notice that HD equals to DH prime and P prime K equals to KP. And both P prime P and H prime are perpendicular to BC, which means P prime P, H prime H. This one is an isosceles trapezoid, right? That means if we connect P prime H and we connect P H prime, we already know that angle HP prime P equals to angle P prime P H prime, right? This angle equals to this angle, right? This one equals to this one. So because we know that P prime K equals to KP, right? Still remember our target is to prove that KP equals to HS, right? And we already know that P prime K equals to KP. So if we can prove that P prime K equals to HS, then we just prove that KP equals to HS, right? And look at here. We know that P prime K is in parallel with HS. And if P prime K equals to HS, that make P prime K SH to be a parallelogram, which means P prime H is in parallel with KS. Right? So we just need to prove that P prime H is in parallel with KS. Then we prove that P prime K SH is a parallelogram, right? So to prove that this is a parallelogram, we can think of to prove that this angle equals to this angle, the angle L or angle SKP, right? Now we want to prove angle HP prime K equals to angle SKP, right? We want to prove this angle equals to this angle. Let's just extend the P prime P and meet the circumcircle on point T, right? Because PT and AH prime are parallel lines that intersect the circle, right? So we know that the arc TH prime equals to arc AP. That means the circular angle reference to these two arcs are equal, right? And we know that the angle P prime PH prime, P prime PH prime, this angle is referenced to TH, the arc TH, right? So that means this angle equals to any angle referenced to arc AP, which can be easily defined as angle ABP, right? So we know that angle P prime PH prime equals to angle ABP, right? This one equals to this one, the angle ABP. And because PK is perpendicular with BK, that make angle BKP as 90 degree. And we know that PJ is perpendicular with AB, make angle PJB as 90 degree. So JBPK are cyclic. That means the angle SKP equals to angle JBP or angle ABP, right? So we know that JBPK are cyclic. And then we know that angle SKP equals to angle ABP. Okay, now look at this one. Angle SKP equals to angle ABP. Angle ABP equals to angle P prime PH prime. And angle P prime PH prime equals to angle HP prime P, which means angle HP prime P equals to angle SKP, right? What is HP prime P? HP prime P, this angle equals to angle SKP, right? Equals to this one. So then we know that P prime H is in parallel with KS. And because P prime K also in parallel with HS, we know that let me just put it here. So we know that P prime KSH is a parallelogram, right? This is a parallelogram. That means P prime K equals to HS. And we know that P prime K equals to KP. So we know that KP equals to HS. And KP is in parallel with HS. Make KHSP to be a parallelogram. Right? Therefore, HP and KS equally bisect each other, which means Q is, let's just say that the Simson line equally divides the pH, segment pH, right? So we got what we need. That's for the first question, we just prove it. And for the second question, let P on arc BC, it's already on arc BC. The symmetrical points from P to AB and AC are MN respectively. So we do symmetrical point, then we just extend PL, right, to N. That make Ln equals to PL. So let's call this point as N. And for this one, we extend PJ to a point M. Right? So we know that MJ equals to JP and perpendicular with AB. Right? We want to prove that MNH are collinear. MNH are collinear. Right? Notice that PJ to PM equals to 1 to 2, right? Equals to PQ to PH equals to PL to PN, right? And we already know that JQL are collinear. So MHN are collinear. That's it. So if you just think that we don't have all of this knowledge to directly prove that MNH are collinear, it's not a very easy thing, right? Okay. Just a quick review for this problem. The key part is that how I address to prove that P prime to prove that KP equals to HS, right? This auxiliary line took me some time to figure it out because I suddenly realized that I can do this just because HD equals to DH prime, right? So once we do this, we make a isosceles trapezoid, and based on that, we have more angle relations. Okay. I hope you like this problem and this video. See you in next one. Thank you.